Calculate the final speed of a solid cylinder that rolls down a 2.00 meter high incline. The cylinder starts from rest, has mass of 0.75 kilogram, and has a radius of 4.00 centimeter. Alright, so what are we given here? The height of the incline, 2.00 meters. And mass of the cylinder, which is equal to 0.750 kilograms. And has a radius of 4 centimeters. It's converted to meters, that will be 0.04 meters. And what we are asked to find is what the final velocity is. Alright, let's get the situation here. We have an inclined plane, something like this, at a height of certain value h. Make it three-dimensional so that we can see it. So cylinder is at the top of the incline. It's rolling downward. Initially, its velocity is 0. So the only energy we have here is the potential energy because it's at height h. Okay. So if initial velocity is 0, that means angular velocity is 0 as well. All right. So we know that energy is conserved. That means initial energy is equal to final energy. Initial energy is mgh plus kinetic energy v naught squared. That's translational. And then we have kinetic energy rotational. And then we have potential energy final, mgh 0 in this case, plus half mvf squared plus 1 over 2 moment of inertia omega f squared. So we know this one is 0, and we know this one is 0 too, because initial velocity is 0, angular initial velocity is 0, so the only thing we have here is mgh. And we know the potential energy at the bottom is 0, that's the reference point, therefore this is 0. So we have half mvf squared as translational kinetic energy, and 1 over 2 I is a cylinder, therefore it's going to be 1 over 2 mass times r squared, radius squared. And instead of omega f, we are going to write vf over r, because omega f is equal to vf over r. So now we can see m is in all terms there, therefore we can divide both sides by m. We can cancel out m. Alright, so we have gh on this side, half vf squared on this side here, plus 1 over 2 times 1 over 2 is 1 over 4, and r squared here cancels out with r. Remember there is a 2 here, squared. Therefore, that's gone. So we are left with VF squared here. 1 over 2 VF squared plus 1 over 4 VF squared is 3 over 4 VF squared. Multiply both sides by 4 over 3. Find the square root, yields VF equals to the square root of 4 over 3 GH. Plug in the numbers. 4 over 3 times the gravitational acceleration times the height. That's 2 meters. That's equal to 5.11 meter per second.